So what we do, we'll do the nitrogen pressurization, inject the nitrogen up to the around 200 psi pressure. Then we are going to depressurize via RO, open the vent and control the discharge to flare. And repeating with this cycle till we are getting the gas-free criteria. As per the company standard, or we are saying that if we need that less than 0% hydrocarbon for the entry into the reactor. Then there is a key design safety features are RO ensures the controlled flow, means there is no operator is dependence. Choke flow regimes governs the discharge. No significant liquid carryover expected because our operation is going to start at a once the liquid is transferred from one bullet to other, there is a very minimum or we can say very residual LPG is there. So we are not saying that any significant of the liquid carry over to the flare. And the flare system is handle the low intermediate gas load, and the system is designed for the simplicity and the reliability. So this is a very short presentation for the background for our
Yeah.
what is our project background, what is the sequence, what is the sequence, and what is included in the display.
Yeah, thank you, Kedar. I think I have some few points to clarify. So, Kedar, you are saying that nitrogen pressure will be used to purge the LPG bullet up to 200 psia, and I am sure the volume of nitrogen is not significant to impact the operations of the flare tip, right? It will not impact the flare tip.
Yeah, yeah. Actually, what
Okay.
anyway, once the operation people also join, we can understand from them again in our session, this today's session. But what we understood from the operation before that, they are pressurizing to the nitrogen, and the rate of the nitrogen is to be the around from the 1,000 to like a 3,000 to 5,000 SCFH is there. So,
Okay.
and it's depend upon the operations, how long they want to go for the depressurization. It's depend upon that. So we can again
Okay.
understand with from the operation once
Okay.
they are.
So that we will take a note that nitrogen pressure up to 200 psi will not impair the operations of flare. So this is one of the basic design set that I will consider in the HAZOP. And second, you are saying if you go the key design safety features, number two, choked flow regime governs discharge. So only RO, restricted orifice is going to ensure the choked flow, or how you are going to ensure the choked flow? By manual valve?
Yeah, actually, what happened? There is the RO. So what happened? Uh, Upstream of the RO, we have the high pressure, like we are seeing that around the 200 psi or something. And at the downstream is only the atmospheric area. So it's only the one way pass from the RO. The flow is going to control the flare.
Okay, that I agree. So that means bullet